Before rasterizing, let's check out the point velocities and do something to break those up. You always want to do that. It'll help with the mushrooms. It'll help with all kinds of different things. So point velocity, we'll keep the incoming. So we'll say that, turn on our trails, and we can just add a curl noise like so. Maybe take the swirl size down a tad bit, right around there. Let's also add a conical noise and turn that up as well, with a cone angle maybe around here or something. I don't know, something like that. I shall use an attribute noise for temperature right here. And that's about everything we need to start rasterizing this out. So volume, rasterize attributes, density, velocity, and temperature for right now. Go down here, turn off this coverage attribute, set this to 10, normalize. Particle scale of 1 looks pretty good, and then we just blur this out a slight bit. Middle mouse, we have about 500,000 voxels, which is a pretty good size for sourcing things in. Okay, so thinking about what we need. Remember back to our diagram where we want to mask things out? We want to mask out the velocity so it doesn't create those mushroom shapes. Well, we need a field called the influence field. So we have influence and we have influence vel. I have a couple of deletes right here. We're going to create those fields based off of the density. So here is a delete sop that isolates density. So let's plug that in. And then once we have that, we'll just rename it to influence. Now the key here is that if you use this as a mask, then you need to clamp these values like so. So I just made a ramp that pretty much took it all the way out here. If I do a volume slice, you can see that this is turning this into a value of 1, which is good. And then I take a time shift to move it forward by 1 frame so that it's going ahead of where the density and velocity are happening. Just like I described in the diagram in the beginning of this whole section. So we have that. It converts fog to SDF. We then dilate this a little bit and I turn it back into a fog again. Just to make sure that the values are all good, we can see that we now have a mask that looks like this. So that's what's happening for the influence. The influence velocity is the same thing, except this time we just need to change this to influence vel. And so the mask is going ahead of the velocity, so I don't want to time shift this. The velocity happens at the normal time, but the mask is ahead of the velocity so that the values have something to go into when it moves forward. So for more information on that, again, check out the video that I made at the beginning of this whole section that explains this whole thing with the diagram. So that will now give us density. I would like to eventually have some fuel for some combustion. We'll take some particles and have them stream behind these spikes. But we will get to that here in a little bit. So we'll save that for later. Here is our terrain. We're going to use that as a collision. So again, that's just using collision and collision velocity like I've explained before. All of those guys get brought down here to the merge. And one last field we need to bring in is the velocity of the main simulation. So I'd like to blend in whatever the spikes do to the main simulation. And we could just take the velocity of that main pyro plume. We can downsample it so that there's not as many voxels happening as the final quality. And then we can use that velocity to basically twirl this density around as if it was part of the main sim. So that means we'll take our sparse cache, bring it in, isolate velocity, and then resample it so that we're only left with around 700 to 800,000 voxels. Once we have that, we'll merge it in down here, cache it out, and at the default settings, we end up with this. Now, I'm not going to lie. It's going to take a few iterations from the default settings that we see right here to get this dialed in. You'll have to go through, adjust the velocity on the influence velocity, the velocity from the main pyro simulation to blend it in. You'll have to go through a few rounds of this. But the main idea here is that we want to try to blend this in as much as we can to that main plume. and we want that offset from the initial impact. We see that offset all the time in reference, and it's happening right here, but the spikes are just going too far. One thing you can do to try to dial in how far out these spikes go is multiplying the source at a certain point along here. So if you like the speed that the spikes are going here, what you can do is overshoot it like I have right here, and then just multiply the density so that it reaches a value of 0 around, let's say, frame 42. That way, it doesn't keep shooting outwards after that. That will give you a more specific timing to this whole thing. However, like I said, I'm going to just pause the video, give this a couple of rounds. You guys have seen what these settings generally do at this point, so I'm going to assume that you're capable of just trying this a few times yourself. One thing I also highly recommend doing is taking a look at reference and going back and forth between this and the spikes that you're trying to make. In this situation, I want to use this reference. I'm actually going to count how many frames these spikes are visible before they turn into the cloud. So we have frame 1 right here, and I'll pause the video as I go through frame by frame until these sort of spikes are no longer there. Okay, and it looks like we have about 27 frames before these spikes disappear and they start turning into the cloud. So I know that in this situation, if I'm trying to match this, I want to go forward 27 frames. In this case, that'll be about frame 57 when that all happens. So right now the spikes are moving too quickly. We can turn down the velocity or how quickly that simulation evolves. And on top of that, we also want to be sure that they disappear not at frame 48, but actually frame 57. And so do try to be specific about the effects that you're trying to do. Also, if you want to manually get rid of some of these spikes, that's cool too. And we also want to take these spikes and make it so that they are, again, following roughly the speed of the surrounding plumes a bit more. One thing we will do is we will add more body to these spikes as it goes through. So we don't want the spikes looking this sharp, but I'll show you how to do that once we have a better base animation to work with. In our viewport, it's useful to take the cached version of our plume and overlay that up here with our trail paths. So if we do that, we can visually see where everything could be at around frame 57. And then from there, we can see what's happening with our trail source. And it looks like our trail source is lagging behind a fair bit. And so one thing we'll try to do is also go up here to our trail paths and turn up the speed. So if we go under the trail generation tab, we can then take our speed scale up until our spikes are in a place that's slightly beyond this cloud around here. Or actually, we'll go a bit further than that even. So probably right around here or so. Looks pretty good. We then go down to our trail source. We want to make sure that we still have some density spawning here, but not much. So we turn this over to the right until we start seeing this come back. Also, if you've keyframed this default value up here, then we can just take this and have it so that it's almost 0 at about this point in the simulation. So we have the location of where this density is spawning, and we also have the amount that's keyframed by this default value on the particles. That will help control the overall timing of everything. You'll want to keep adjusting the speed of everything, the fall off of the density, until you land with something that's about right here. As I said before, really be sure that you're looking at reference when you do this. And I'll probably go back and actually change the rate of density spawning here. We're probably at about whites, and then looking at this guy over here, he's already pretty far out, so I want him to be closer towards black at that point. But anyway, this takes a lot of back and forth. Take your time on this. Be sure that this lines up. Don't simulate this 100 times. Try to just do these play blasts with the particles and the cache. But do make sure that your cache is also the resolution you want the final thing to be. Because as we've seen before, if you go more coarse, then it'll take the poofs further outwards because of velocity. But anyway, this is what we end up having. I'm going to go through probably one more round of it. In the next video, I want to show you how to add more body to the simulation. We're going to spawn some particles. We're going to then blend that in with the velocity of what's going on with our main plume, and we'll take it from there.